This video, we're going to talk about how to multiply radicals. The problems that we're going to talk about are like those from 15.4, numbers 1, 3, 5, 9, 11, 13, 15, 17, 19, 23, 27, and 29. So basic rule that we're going to use here is that the square root of a times the square root of b is equal to the square root of a times b. And we may go the other way as well and break some square roots up with something on the inside that we want to factor it and break it up into smaller square roots. But let's go ahead and let's start here with something like 15.4, number 1. The square root of 2 times the square root of 72 is going to be the square root of 2 times 72 is the square root of 144. 144 is a perfect square. It's 12 squared, so the answer is 12. Number 3, square root of 7 times the square root of 14. I'm going to go the other way and break 14 up, that this is going to be the square root of 7 times the square root of 7 times the square root of 2. The square root of 7 times the square root of 7 is 7 times the square root of 2, or 7 square roots of 2. That was like number 3. Our next problem is like number 5. The square root of 5 squared is going to be the same as the square root of 5 times the square root of 5, which is the square root of 25, which is 5. Anytime that we square a square root, it's going to make the square root go away, and we're going to get what's inside the square root sign. So we should be able to come all the way back here and just write 5, because the square root of a squared is equal to a as long as a is greater than or equal to 0. Next one here, 6 square root of 2 squared is equal to 6 squared times 2 is 36 times 2 is 72. That, remember that when I have a power raised to a power, I multiply the exponent. So 1 times 2 is 2. This is 2 to the 1/2. 1/2 times 2 is 1. 6 squared is 36. 2 to the first is 2. 36 times 2 is 72. Right. Let's go ahead and look at the next one here. 4 times the square root of x squared, and we're going to assume that all the variables are positive numbers. So this is going to be 4 squared times x is going to be 16x. We have the square root of 7x to the 7th times the square root of 14x. This is going to be the square root of 7 times the square root of 7 times 2 times the square root of x to the 7th times the square root of x. It's going to give us 7 square root of 2 times the square root of x to the 8th. Remember that this is an index of 2, so this is going to be 8 divided by 2 is going to be 4. And because this is an even power on the outside, we don't need to worry about if this was a positive or negative number inside. If this had been an even on the inside and an odd on the outside, then we would have had to have put absolute value bars around it. Um, Right, square root of 4xy squared times the square root of xy is the square root of 4 times the square root of x times x is x squared. So square root of y squared times y is y cubed. This is going to be 2x and then a y square root of y. And they tell us to assume that all of the variables are positive. If they didn't tell us that, we'd have to put absolute value bars around x and y or around the entire x times y. Now we're going to multiply and simplify. This is going to be the square root of 7 times 6 is 42. And 5 times 6 is 30. And there are no perfect squares that are factors of 42 or 30. This is a 2 and a 3. There's no 2's or 3's over here. So we're done. It's as simple as we can get in this problem. Let's change it up a little bit now and make it the square root of 6 times the square root of 3 plus the square root of 2 is going to be the square root of 18 plus the square root of 12, which is the square root of 9 times 2 plus the square root of 4 times 3 is the square root of 9 times the square root of 2 plus the square root of 4 times the square root of 3 is 3 square roots of 2 plus 2 square roots of 3. Now we have the square root of 13 plus 2 and the square root of 13 minus 2. This is a difference of squares. But let's go ahead and multiply it all out. The square root of 13 times the square root of 13 is 13. Then we're going to have minus 2 times the square root of 13 and plus 2 times the square root of 13. 2 times negative 2 is negative 4. These two terms here make a 0. And 13 minus 4 is 9. Now we have 3 times the square root of 13 plus 1 and the square root of 13 minus 9. 3 times root 13 is 3 times root 13 times root 13 is 3 times 13. 3 root 13 times negative 9 is negative 27 root 13. Plus 1 times root 13 is root 13. 1 times negative 9 is negative 9. 3 times 13 is 39. Let's just put a 1 there. It's going to be minus 26 root 13. 39 minus 9 is 30. And we've completely simplified it because 13 is a prime number. We can't break that down anymore. One more problem in this video. And that will be the square root of x plus 4 times the square root of x minus 4. Square root of x times the square root of x is x, minus 4 root x plus 4 root x. 4 times negative 4 is negative 16. This simplifies to x minus 16. So I hope you can see that there's some things we can factor using the difference of two squares and square roots that don't look traditional to us. For instance, if I had x squared minus 5, I'd be able to break that down into x plus the square root of 5 and x minus the square root of 5. Or we've already seen x minus 16 could break down into the square root of x plus 4 and the square root of x minus 4. So think about that when you get to the point where you need to factor things. Sometimes you may have to use square roots to help you factor things that are not perfect squares. All right, when we come back next time, we're going to talk about how to divide radicals. Very similar process to multiplying radicals, just a little different because it's division, but multiplication and division are related topics. See you for the next video.